Welcome to the lecture series of numerical methods. Today we are going to discuss about interpolation with unequal interval. In the previous lecture we have discussed interpolation for equal interval, and now we are going to discuss a topic of interpolation with unequal interval. There are two interpolation formula for unequal values of x. The first one is Lagrange's interpolation formula and the next one is Newton's general interpolation. In this case of Newton's general interpolation with the divided difference, the previous one we have seen only difference table. In this one, divided difference method, while we are doing the problem we can understand the difference between ordinary divided difference and difference table. Okay, so the first one is Lagrange's interpolation formula. Look at the formula. What is the Lagrange's interpolation formula? For a given equation y equal to f of x takes the value y is equal to y naught to yn and x takes the values x naught to xn. Then the polynomial f of x is equal to x minus x1 into x minus x2 etc. x minus xn whole divided by x naught minus x1, x naught minus x2 etc. into x naught minus xn into y naught. This is first term. The next one is x minus x naught, x minus x2 into etc. x minus xn whole divided by x1 minus x naught into x1 minus x2 etc. x1 minus xn into y1. Continuing like this, and the nth term will be x minus x naught into x minus x1 etc. x minus x n minus 1. Here it is written x n minus 1. Okay, here also it suffix x n minus 1 into yn. This formula is known as Lagrange's interpolation formula for unequal interval. How to remember this formula? There is an easy way to remember the formula. The thing is, we have the x value from x naught to xn. Likewise, the y value is y naught to yn. Okay. So, in the first term of the formula, the numerator without x naught, we have to multiply the remaining values like this, x minus x1, okay, into x minus x2 into etc. x minus xn. There is no x naught in the numerator. Divided by, in the denominator, x naught minus x1, x naught minus x2 etc. x naught minus xn. So, in the whole denominator, from x naught only we are subtracting all the terms. Okay. So, easily we can remember the first one. How it is? In the numerator there won't be any x naught. In the denominator, for all the term we are subtracting from x naught into, here it is x naught, no, the corresponding y value is y naught. So, this is the first term. Likewise, for the second term, x minus x naught, here x naught is over in the numerator, isn't it? The next term in the x value is x1. So, in the second term, there won't be any x1 in the numerator. So, x minus x naught into x minus x2 into etc. x minus xn whole divided by, in all the terms in the denominator, we are going to subtract with the x1. Okay, so x1 minus x naught, x1 minus x2 etc. x1 minus xn into y1. So, this is the second term. Likewise, for the nth term, okay, for the nth term, x minus x naught, x minus x1 etc. x minus xn minus 1. So, in the numerator, there won't be any x nth term. Okay, in the denominator, for all the terms we are going to subtract with the xn. So, xn minus x naught into xn minus x1 into etc. xn minus xn minus 1 into yn. So, this is the way we have to remember the formula of Lagrange's interpolation formula for unequal interval. Okay. There is a note. Look at the note. Lagrange's formula can be applied whether the value of xi or equispaced or not. So, what is the note represents? The note represents that this formula, that is the Lagrange's formula, can be used for equispaced of x values or not, in the sense whether the x data is equally divised, that is the equispaced x data, or if it is unequal. Okay, so if it is equispaced means the interval of xi's are equal, or if it is unequal also we can use, but the topic is this formula is only applying for the unequal only. But what is the note says that we can apply the formula for equal interval also. That is what the note says. The note says that the Lagrange's formula can be applied whether the value of xi are equispaced or not, whether it is equal interval or unequal interval. In both the case we can apply the Lagrange's formula, we can get the result. That is what the note says. So based on this result, look at the first question. Using Lagrange's, split a polynomial for a following data at x is equal to 2. What is the x data? X data takes, x takes the value 0, 1, 3, 4 and y takes the value minus 12, 0, 6, 12. So based on these values only we are going to apply the Lagrange's polynomial. Okay. Look at the solution. From the given data, first we are supposed to write the x0, x1, x2, x3 values. So from the given data, x0 equal to, what is the x0? x0 is 0, x1, x2, x3 and corresponding y values are y0, y1, y2, y3. So from the given data, x0 equal to 0, x1 equal to 1 and x2 equal to 3, x3 equal to 4. Similarly, y0 equal to minus 12 and y1 equal to 0, y2 equal to 6 and y3 equal to 12. So after written this, we are going to write the Lagrange's formula for the given data. So in the given data, the x takes the value x0 to x3. So only x0 to x3, corresponding the y value takes y0 to y3. So only 4 values. So in the general formula we are going to take only up to the x3 and y3 term alone. Okay. Look at the formula for the given data. Y equal to f of x, x minus x1, x minus x2, x minus x3, because the given data up to x3 only, divided by x0 minus x1, x0 minus x2, x0 minus x3 into y0. The second term is x minus x0 into x minus x2 into x minus x3 whole divided by x1 minus x0 into x1 minus x2 into x1 minus x3 into y1. Okay. So the second term over. Then the third one is x minus x0, x minus x1, x minus x3. Here there won't be any x2 in the numerator. In the denominator, all the terms subtract from x2. So x2 minus x0, x2 minus x1, x2 minus x3 into y2. The last one is x minus x0, x minus x1, x minus x2 divided by, there won't be any x3. Okay, the divided by x3 minus x0, x3 minus x1, x3 minus x2, corresponding y value is y3. So this is the formula for the given data. Okay, so in this formula we are going to substitute all the values of x and y. Substituting this one for the avoiding the error, substitute all the values according to the formula. After this, simplifying this, we can get the right answer. Okay, wherever x0, x1, x2, x3 comes, we have to substitute all the values in the formula. Simplifying this, we can get the answer. So after simplification, we are getting the answer as y equal to f of x is equal to x cube minus 7x square plus 18x minus 12. So this is the required polynomial for the given data. In this question, the question is not completed. Here, find the polynomial for the following data at x is equal to. What is this at x is equal to 2? In the sense that after find out the polynomial, we have to put the x value as 2. Okay, so put x is equal to 2 in y. So what will happen? So put x is equal to 2. Okay, so which implies y is equal to x cube, that means 8. Okay, so 2 cube minus 7 into 4, x square is 4 plus 18 into 2 minus 12. So 8 minus 7 4s are 28 plus 18 into 2 36 minus 12. Adding the negative values minus 40. So 36 plus 8 44 minus 40. So our y answer is y is equal to 4 at the point x is equal to 2. So this is the way we are supposed to do the problem under Lagrange's formula. Okay, so in this one, how to do the problem under Lagrange's formula? First, for the given data, we are supposed to write the x0, x1, x2, x3 values. corresponding to the values, that is according to the value of given x data, we are writing the formula for given data y equal to, likewise we are supposed to write the formula. After write out the formula, we have to substitute all the points in the formula. Simplifying this, we are getting the answer as a polynomial. It should be a polynomial. Okay, so if the question is only find the polynomial, means we are supposed to write up to this only. If the point is given, if suppose the question is find a polynomial at the point x is equal to 2, likewise given in the question. If suppose the point is not given, we can stop up to the polynomial. So in this question the point is given, that means after find out the polynomial, we have to put the given point in the polynomial. So we are getting the required answer as 4 for this question. So this is the problem under Lagrange's formula for unequal interval. You can see that all the x value in the given question is not equal. So the value of x is not equal, unequal values. So we can say the formula for Lagrange's for unequal interval. If suppose for equal interval, can we apply this formula? Yes, we can apply this formula. Okay. Thank you for watching.